back in it again with another video, and this will be the discussion on our inventory project for free energy using magnet. So magnetic standing slash spinning pen. So did you know that magnetic standing pen works? In this project, you'll discover how to place magnets so they either attract or repel one another, and then use that information to stand a pen. So magnets have two poles. What are those poles? Of course, the North Pole and the South Pole. So when two magnets are placed together like poles, north to north, it repels. And unlike poles, attract. So if it faces North Pole to South Pole, then the magnet attracts. An invisible magnet field surrounds a magnet. Yes, the North Pole of a magnet points closely towards the Earth's North Pole, and the South Pole points towards the Earth's South Pole. This is because the Earth itself has enough magnetic materials in it to be considered one enormous magnet. Isn't that amazing? So for the fifth basic information, you can turn an unmagnetized piece of iron into magnetic or into a magnet by simply running magnetized object over a few times. So this process is called magnetization. So this is the methodology. I will just present the materials needed. We have to use old CD, pen, ring magnets. We need 2 ring magnets, tape, bicycle spoke, pliers, and scissor. So for the results and discussion, in the configuration used in our project, lifting force is provided due to repulsion between back magnets. So stability is due to attraction between front magnets and frictional force at the tip of the pencil or the pen that we use. So hence, the following forces are involved in standing ovation. So first, gravitational force of the pencil or of the pen and the magnet. And then frictional force at the tip of the pencil, attractive force of magnets on the front of the pencil, and repulsive force between the back magnets. So for example, we have to find this given. The 0.2 kilogram pen stands in divided disc with the radius of 2 meters. If the pen rotates 3 seconds in period, what is the speed and force of the pencil to make it stand and spin? So we have to find the speed and the force. So we are given the radius of 2 meters, and then the time of 3 seconds, and then the mass of 0.2 kilogram. We have to find the speed and the force. So if we are asked to find the distance, then D is equals to 0, or the distance is equivalent of 0 because it is stationary. So for the solution, we have to use V is equals to 2 pi r over T, and this is the formula that we're going to use for velocity, or just the same with the speed, velocity and speed, that is the same. V is equals to 2 to the quantity of 3.14 to the quantity of 2 meter, since the equivalent of pi is equals to 3.14, and then our radius is 2 meter over time na 3 seconds. So simplify it all, we got velocity is equals to 4.2 meter per second. So that is our speed. And for the force, we have to use the formula F is equals to mr squared over r. There are another appropriate formulas for this, but let me use this one. So F, let's simplify our mass, which is 0.2 kilogram, to the quantity of our radius. This must not be the radius, but this is the value of our velocity, so which is 4.2 meter per second. So typos error po tayo dito. Squared po natin, and then over our radius na 2 meter po. So simplify natin, we got 1.8 kilogram meter per second squared, and we got the force of 1.8 joule or meter per second square, that is joule in math. But the most appropriate unit for Newton, I mean for force, the most appropriate unit for force is Newton, or big letter N. So that's all. Thank you.